So good afternoon children, we will continue with the chemical kinetics. Only 3 topics are left out now, with that the chapter will be getting over. So we will continue with the same chapter, that is chemical kinetics. First let me write what are all the topics that we have covered so far. Okay. So from chemical kinetics we started with the definition for chemical kinetics. We started with this. Then what is meant by rate of chemical reaction, what is meant by rate of chemical reaction, what is average rate of chemical reaction. For the average rate of chemical reaction we plotted a graph, very important question, that is graph for the product and similarly the graph for the reactant. Then based on average rate, instantaneous rate also we calculated, isn't it? Average rate of chemical reaction. Next to the average rate of chemical reaction we studied about the rate law or the rate expression, rate law and rate expression. Next one, what is meant by the molecularity of a reaction? What is, we studied what is meant by molecularity of reaction. Next to the molecularity of the reaction we studied the differences about order and molecularity of reaction, order and molecularity of the reaction. Next to that we studied about what is zero order reaction, what is first order reaction, what is the pseudo order reaction with the derivation part, isn't it? With the derivation part we studied. Next to that we studied about the off-life period, off-life period for both first order and for zero order we studied, isn't it? So these are the topics that we have covered so far. The left out portions pathina temperature dependence rate constant, temperature dependent rate constant. Next one is effect of catalyst, last one is collision theory. So these 3 topics are left out, that we will see it now. And from all these topics which we have covered so far, we have done the in-text as well as example problems. We have completed, we have done. Okay, so what are all the topics that we have studied? And today we have to study temperature dependent rate constant, effect of catalyst, and the other one is called as what? Collision theory. Idoda kuda chende textbook back there are 30 sums are there, and the 30 sums also we have to do it. It's a very easy, which is actually based on the in-text sums which I have given. No, based on that only the 30 sums have been given in your textbook back question. Okay, so that is also easy. Now we will continue with temperature dependent rate constant. What is the topic? Temperature dependence rate constant. What is this rate? Rate is nothing but it is the speed of chemical reaction. What is rate? It is the speed of the chemical reaction. Define rate. Rate is speed of chemical reaction. Upper the speed of chemical reaction, which is called as a rate, depending on what? Depends on the temperature. That's the topic. So temperature plays a very, very significant role in determining the speed of a chemical reaction. So that means what? Whenever the temperature is high, the rate of chemical reaction will also be high. So whenever the temperature is high, the rate of chemical reaction will also be high. So that means what? The temperature will be directly proportional to the rate of chemical reaction. So rate of chemical reaction. Say for example 1, we take 2 molecules of nitrogen pentoxide. What we are doing? We are taking 2 molecules of nitrogen pentoxide. This nitrogen pentoxide, on heating, it gets decomposed, giving rise to the formation of 2 molecules of N2O4 nitrogen tetroxide. Along with that, oxygen is getting liberated. Now, to complete T off of the reaction. What is meant by T off? T off is nothing but off life. What is meant by off life period? Off life period is the time taken to reduce the initial concentration of the reactant to 1/2 of its concentration. Say for example, I am taking a reactant and reactant reacts to give rise to the formation of a product. Half life period reactant reacts to give rise to the formation of a product. Initial concentration of the reactant it will be 100%. Why? Because the reaction hasn't get started. The concentration of the product, initial concentration will be 0. In a reaction nadakala. But when the reaction proceeds, what happens? The concentration of the reactant goes on decrease with rapid increase in the concentration of the product. What will happen here? 100% will become 99, 98, 97, 96, like that it goes. Here the concentration goes on increase, that means 0, 1, 2, 3, 4, 5, like that it get increases. But there is a concentration where the concentration of the reactant and the concentration of the product will become 50. Now the concentration of the reactant will become 50. So the initial concentration 1/2 of the concentration reduce ஆகிறதுக்கு எடுத்திருக்கக்கூடிய time is called as off life period. அப்போ 100ல இருந்து 50% அந்த reactant concentration reduce ஆக எடுத்துக்கக்கூடிய time we are calling it as off life period. அப்போ what is the definition for the off life period? The time required for the reactant to reduce its initial concentration, that is 100%, initial concentration to half of its concentration is called as off life period. Is called as off life period. So off life period for the decomposition of nitrogen pentoxide at 50 degrees centigrade. என்ன temperature maintain பண்ற 50 degrees centigrade. Similarly, off life period for the decomposition of nitrogen pentoxide, I am maintaining a temperature of about 25 degrees centigrade. Now, off life period for the decomposition of the nitrogen pentoxide at 0 degree centigrade. Different conditions I am maintaining. Maintain பண்ணும்போது off life period for the nitrogen pentoxide at 50 degrees centigrade, it takes within 12 minutes for the decomposition of nitrogen pentoxide to form nitrogen tetroxide. T off 12 minutes. 25 degree degree centigrade, it becomes 5 hours. It takes 5 hours. Temperature and maintain பண்ணல, off reaction நடக்குது. அப்போ nitrogen pentoxide nitrogen tetroxide ஃபார்ம் பண்ணுறதுக்கு எடுத்துக்கூடிய days will be 10 days. அப்போ higher the temperature, faster will be the reaction. 12 minutes product கிடைக்குது. 25 degree centigrade maintain பண்ணுறேன், 5 hours எனக்கு product form ஆகுது. 10 degree centigrade I am maintaining, product formation it takes 10 days. So this is, from this we can understand what is that concept? Whenever the temperature is high, the rate of chemical reaction will be high, isn't it? That is the first example. Example number 1. Now coming to the second example, the potassium permanganate versus oxalic acid. Dicarboxylic acid தான் oxalic acid அப்படின்னு சொல்றோம். Oxalic acid, potassium permanganate versus oxalic acid. இது வந்து permanganometry which you have in 12th standard practicals titrationல இருக்கும். So potassium permanganate will be taking in the burette. Estimation la comparison la potassium permanganate will be taking in the burette. We know the color of potassium permanganate, which is pink color, and we have to pipette 20 ml and we have to load it in the conical flask. Evlo 20 ml of oxalic acid conical flask la edutittu, then immediately the conical flask has to be kept in the water bath, because the oxalic acid oda condition enna pannanom, warm condition ku we have to bring bearable warmth condition, that is 60 to 70 degrees centigrade temperature na maintain pannanom. So appo water bath la vechittu warmth condition, bearable warmth condition vanda piragu then I have to do the titration. The warmth condition of the oxalic acid has a tendency of decolorizing the potassium permanganate. Suppose if the oxalic acid doesn't have the warmth condition, then automatically the decolorization of the potassium permanganate will not takes place. Upper decolorization is not going to take place, then we cannot find out the concordant range. Concordant value cannot be predicted. Understood? So upper estimation, titrametric analysis, titration, estimation irundhalum seri, comparison irundhalum seri, and the normality comparison irundhalum seri, whatsoever it is, the oxalic acid needs the bearable warmth temperature. Bearable warmth temperature. Then similarly, third point is a very very important point. That point frequent exam la kekakudiyadhu, whenever the temperature of the reaction is increased to 10, increased to 10 and 50 degrees centigrade, 60 degree, like that, multiples of 10, 60 degrees centigrade, 70 degrees centigrade. When the temperature is going to increase to 10, 10, 10, then automatically the rate of the chemical reaction will be getting doubled. Rate of a chemical reaction enna agum, double the times the rate will get increased. Appa when the temperature increased to 10, then rate of chemical reaction will be doubled. The rate of chemical reaction will be getting doubled. Understood? So appa temperature dependent rate constant ku நம்ம படிச்சிட்டோம். இப்ப temperature அதிகமா இருந்தா rate of chemical reaction will be high ங்கிறது from these three examples we have understood, isn't it? So based on this concept, two scientists, one is Van 't Hoff, Swedish scientist, Dutch scientist, he is a Dutch scientist, Van 't Hoff, and Arrhenius. Arrhenius, he is a Swedish scientist, Van 't Hoff. The other one is Swedish chemist. Gave the justification for temperature dependence rate constant. Okay, they proposed an equation that is rate is equal to AE minus EA divided by RT அப்படின்னு ஒரு எக்ஸ்பெரிமெண்டலாக அவங்க கால்குலேட் பண்ணி ஒரு ஈக்குவேஷனை அவங்க ப்ரொப்போஸ் பண்ணுறாங்க. ஸோ இந்த ஈக்குவேஷனில் பாரு, யூ ஹாவ் டு அண்டர்ஸ்டாண்ட் this AE is called as an Arrhenius factor, or otherwise it is called as a frequency factor. அப்படின்னா என்ன நான் சொல்கிறேன், frequency factor, or otherwise it can be called as pre-exponential factor. Pre-exponential factor. Next one what we have is EA, isn't it? This EA is called as an activation energy. It is called as what? Activation energy. Activation energy is an additional energy which makes the reactant molecules to react with one another, giving rise to the formation of a product. Activation energy is nothing but it is what? It is an additional energy. So activation energy. R is nothing but it is a gas constant. It is a gas constant. There is a value for the gas constant, that is 8.314 joules Kelvin inverse mole inverse. Okay, then T is nothing but it is a temperature. So this is called as what? Arrhenius equation. This equation is called as what? This equation is called as Arrhenius equation. We are calling it as Arrhenius equation. Arrhenius equation. So Arrhenius equation. Arrhenius equation rate is equal to minus EA divided by RT. So A is nothing but Arrhenius factor or the frequency factor, the pre-exponential factor. EA is nothing but it is an activation energy. R is nothing but it is a gas constant, that is 8.314 joules Kelvin inverse mole inverse. T is nothing but it is a temperature. In the equation you have to understand one thing. The rate depends on this Arrhenius factor, which is raised to its exponential power, that is EA. In the EA minus. What is EA? It's an activation energy. Whenever the temperature is high, the rate will be high. Similarly, second condition, whenever the temperature is high, the activation energy should be low. Temperature is high, the activation energy value should be low. Okay, so temperature is high and the activation energy is low, then the rate will be high. Suppose vice versa, if temperature is low and the EA value is going to be high, then the rate of the chemical reaction tends to be low. Rate of chemical reaction will be tends to be low. So Dutch scientist Van Toff and Swedish chemist Arrhenius scientists have proposed the concept of temperature dependent rate constant or equation. That equation is what? Rate is equal to AE minus EA by RT, which is an Arrhenius equation, which is called as Arrhenius equation, where AE will be nothing but Arrhenius factor or the frequency factor, which is a pre-exponential factor, and EA is nothing but activation energy. R is nothing but it's a gas constant value is 8.314 joules Kelvin inverse mole inverse. T is nothing but it is a temperature. So concept another, whenever temperature is high, rate should be high. This first I explain temperature adhigama rate of the chemical reaction will be high. In the equation what is the concept? Whenever through the temperature to be high, so temperature to be high, the activation energy should be low. Another equation derive the activation energy decreased value. Minus they have given. Minus indicates what? The decreased value of the activation energy. Then obviously the rate will be very high. Suppose if the temperature is going to be low, then the EA value will be high. Automatically the rate of chemical reaction will be lower. In the concept to explain further, we have one equation. The equation which or graph that we will see now. That is, say for example, we take hydrogen iodide. We take what? Hydrogen iodide. Hydrogen combines with the iodine, giving rise to the formation of hydrogen iodide. What is it? Example for temperature dependent rate constant equation, hydrogen combines with iodine, giving rise to the formation of two molecules of hydrogen iodide. So now see, hydrogen combining with iodine, as a result it forms a complex, hydrogen and iodine, there is a bond. This I am calling it as intermediate complex. This I am calling it as what? Intermediate complex. Now actually what happens is here, due to the temperature factor, the bond between hydrogen and iodine breaks, and as a result in your hydrogen iodide, here also on hydrogen iodide, all together will be getting two molecules of hydrogen iodide. Now for this we have a graph. In a graph so this is, I am taking it as a potential energy, and this is called as a reaction coordinate. Reaction coordinate is the number of reaction that is taking place at different energy range. Different energy range is called as what? Reaction coordinate. Now the reaction starts. Now the reaction starts and the reaction proceeds till this. Again there is a decline and finally the product is getting formed here. Okay. So now what is the equation? Actually reactant in a hydrogen plus iodine combines. Appa enna here you are getting two molecules of hydrogen iodide to be formed. Now you listen carefully. So the reactant react ஆகும்போது with the help of the activation energy, the reactant molecules are made to go to the excited state. This range is called as what? Excited state, or otherwise called as most probable kinetic energy. The energy that is possessed due to the virtue of its motion. So with the help of the activation energy, the reactant molecules are getting excited and it goes to the most probable kinetic energy. So here it forms the intermediate complex, and from there the intermediate complex will get decomposed or disintegrate like this. The bond gets break, and as a result it gives rise to the formation of a product. Up a product form ஆகும்போது what happens? Activation energy goes on decline. It comes down, isn't it? So நடுவுல இருக்கக்கூடிய ரேஞ்ச் தான் நான் என்னன்னு சொல்றேன், most probable kinetic energy. இந்த most probable kinetic ரேஞ்சுக்கு வரும்பொழுது, probable curve இந்த ரேஞ்சுக்கு வரும்பொழுது the activation energy ஓட activities will get stopped. It makes the reactant molecules to go to the excited state அப்படின்னு சொல்றோம். இப்போ இங்கே நான் என்ன பண்ணியிருக்கேன், இந்த கர்வ் கொஞ்சம் தள்ளி மேலே ஸ்டார்ட் பண்ணி ரியாக்டன்ட் சைடில், ப்ராடக்ட் சைடில் பாரு கர்வை கீழே கொண்டு வந்திருக்கேன். அப்போ ஐ ஹவ் ட்ரான் லைக் திஸ், அகெயின் இட் கம்ஸ் டவுன், தென் இட் கோஸ் ஹியர், அண்ட் திஸ் இஸ் நத்திங் பட் differences in enthalpy of formation. What is delta H? Delta H is nothing but differences in enthalpy of formation. எப்போ differences in enthalpy of formation occurs? When there is increase in the temperature. When there is increase in the temperature. Temperature is getting increase. அதனால தான் என்ன ஆகுது, கீழே இருந்து கிராஃப் ஸ்டார்ட் ஆகாமல் கொஞ்சம் மேலே hydrogen and iodine combines. So there is increase in the temperature. So as a result hydrogen and iodine reacts with one another and forming a complex going to the excited state with the help of the activation energy. Again it comes down from the most probable kinetic curve. So here you are getting the products to be formed. That product is what? Two molecules of hydrogen iodide. The energy difference between the reactant and the product or formation of the product will be delta H. So this is called as what? A graphical representation for the formation of hydrogen iodide, and this indicates what? Temperature dependent rate constant. இதை நம்ம என்னன்னு சொல்கிறோம்? Temperature dependent rate constant அப்படின்னு சொல்கிறோம். ஸோ இதில் நல்ல ஞாபகம் வச்சுக்க வேண்டியது என்ன அப்படின்னு பார்த்தா, நான் ஏற்கனவே எழுதி போட்டேன் கான்செப்ட். என்ன கான்செப்ட்? டெம்பரேச்சர் ஷுட் பி ஹை, rate of chemical reaction will be high. Temperature should be high, automatically the activation energy will comes down, and as a result the rate goes on increase. So this is the main concept based on the equation. This is for what? Temperature dependent rate constant. This is a derivation. The derivation also we will write now. Again we will revise. What is the temperature dependent rate constant? Temperature dependent rate constant na definition anga statement li you can understand. The rate means what? The speed of chemical reaction. The speed of the chemical reaction depends upon the temperature. So whenever the temperature is high, the rate of chemical reaction will also be high. So temperature will be directly proportional to the rate of chemical reaction. For example, two molecules of nitrogen pentoxide decomposes to form nitrogen tetroxide plus oxygen. அதுக்கு ஆஃப் லைஃப்ல different time periodல எவ்வளோ நேரத்தில் the reaction is taking place I have given. Second example is potassium permanganate versus what? Oxalic acid. So for oxalic acid, we have to maintain the bearable warmth temperature that decolorizes the potassium permanganate. Then temperature, whenever there is increase in temperature to 10 times, automatically the rate of the chemical reaction will be getting doubled. Then Dutch scientist Van 't Hoff and Swedish chemist Arrhenius, they propose the concept of temperature dependent rate constant. So that is rate will be equal to AE minus EA by RT, which I am calling it as Arrhenius equation. AE is nothing but Arrhenius factor or frequency factor, let it pre-exponential factor. EA is nothing but activation energy. R is called as a gas constant. The value is equal to 8.314 joules Kelvin inverse mole inverse. T is nothing but temperature. So what is the concept? Whenever the temperature is high, the activation energy will be low, then rate will be very high. So in the concept ஞாபகம் வச்சுக்கணும். So temperature higher இருந்தா automatically activation energy will be lower. Another equation they have given minus EA. Activation energy will be lower, then the rate of the chemical reaction will be very high. So இதை பேஸ் பண்ணி தான் hydrogen iodide formation அதுக்கான graphs I have given for you. Now we go for the Arrhenius equation. ஒரு derivation you have, அது பேஸ் பண்ணி தான் you have a problems. Textbookல you have sums that also we have to do. We go to the derivation part, Arrhenius equation. Arrhenius equation. What is that Arrhenius equation? Rate. Rate ன்னு எழுதலாம், or otherwise I can write it as what? K கூட எழுதலாம் இல்லையா? K will be equal to AE minus EA by RT அப்படின்னு எழுதலாம். ஸோ இது கூட நான் ஒரு கிராஃப் போடலாம். அதே ரியாக்ஷன் கோஆர்டினேட், reaction Rங்கிறது reaction coordinate, this is potential energy. Now you see the intercept, okay? Intercept, and here you have got the reaction coordinate. இப்போ நான் என்ன செய்கிறேன்னா, I am taking the intercept ஓட வேல்யூ இருக்குது, EA by RT இருக்குது, அதுக்கப்புறமா K என்ற வேல்யூ also they have given, isn't it? So now I am taking the ln value of K here along the x-axis, and similarly here the intercept will be the ln of AE. அப்போ எனக்கு வரக்கூடிய ஸ்லோப் எப்படி இருக்குது புரியுறதா? இந்த வேல்யூ நான் எப்படி எழுதுறேன்? ஐ எம் applying ln value on both sides, அப்போ இந்த ஈக்குவேஷன் எப்படி எழுதலாம்? ln of K will be equal to, isn't it, ln of AE minus EA by RT now, isn't it? So ln of K will be equal to ln of AE minus EA by RT. அப்படி எழுது. அப்படி இல்லைன்னா இன்னும் கூட ரொம்ப கரெக்டாக எழுதணும்னா மைனஸ் EA by RT ப்ளஸ் ln of AEன்னு கூட எழுதணும். So this will becomes what? Overall reaction. இப்போ நான் இந்த ஈக்குவேஷனுக்கு I have plotted a graph. அப்போ பாரு, ln K I have taken it here on the x-axis. EA by RT will be the slope minus EA by RT. This is nothing but it is a slope. இந்த இடத்துல intercept reaction எங்கே ஸ்டார்ட் ஆகுது? intercept point என்னது? ln of AE is the interception point. So I am getting a straight line slope, declining slope, straight line எனக்கு கிடச்சிருக்கு. So applying the ln values on both the sides, we got this equation, that is ln of K will be equal to minus EA by RT plus ln of AE in எழுதியாச்சு. Now we are taking temperature as T1. So what will happen? Ln of K1. So let it be equation number 1, let it be equation number 2 now. So temperature is T1. So therefore it is K1 is equal to minus EA divided by RT1 plus ln of AE. So this becomes equation number 3. Now taking different temperatures, temperature as T2. So what will happen? Ln of K2 will be is equal to minus EA divided by RT2 plus ln of AE. So this becomes equation number 4. Now subtracting the equation number 3 from 4. Subtracting the equations, what we have to do? We have to next step is subtracting the equations. Equations subtract panna enna agum? Ln of K2 minus K1 will be is equal to minus EA becomes plus EA by RT1 minus EA divided by RT2 now. This and this becomes cancelled. இல்லையா? இப்போ என்ன எழுதியிருக்கேன் நான்? ln of, correct? Ln of K2 minus K1 will be equal to EA by RT1 minus EA by RT2. Next step, ln of K2 minus K1 will be equal to எதை காமனாக எடுக்கலாம்? EA by R. I am taking it as common. இப்போ பேலன்ஸ் இருக்கிறது என்ன இருக்குது? 1 divided by T1 minus 1 divided by T2 because I am taking EA by R as common. இல்லையா? காமனாக எடுத்துட்டேன். So what I am getting? ln of K2 minus K1 will be equal to EA by R into 1 divided by T1 minus 1 divided by T2. Next step, I am writing it as ln of K2 by K1 will be equal to EA divided by R into, on cross multiplication it becomes T2 minus T1 divided by T1 into T2 now. Correct? Now I am converting ln into log. So what will happen? 2.303 into log value of K2 divided by K1 will be is equal to EA divided by R into, ஏன்னா ln value and log convert பண்ணோம்னா value is 2.303 into log is equal to ln value. But 2.303 into log K2 divided by K1 will be equal to EA by R into T2 minus T1 divided by T1 into T2 it becomes. Next step enna agum? I have to find out only the log of K2 divided by K1 common. Log of K2 divided by K1 will be is equal to EA divided by 2.303 into R into logarithmic value of T2 minus T1 the whole divided by T1 into T2. This is called as overall Arrhenius equation at different temperatures. Arrhenius equation at different temperatures. This is called as what? Arrhenius equation. Arrhenius equation using K value, R value, activation energy, Arrhenius factor, frequency factor use பண்ணி we have derived. Okay, so Arrhenius equation எப்படி derive பண்ணிருக்கோன்னு பார்த்துட்டு இந்த equation use பண்ணி தான் we will be having problems from your in text and similarly from your book back also. Hope you can understand this Arrhenius equation and temperature dependent rate constant. Okay, now we pass it on to the textbook exercise, textbook in text problem. So now see the example sum 4.5 and it is in your textbook page number 115. We'll start with 4.9. The rate constant of a reaction at 500 Kelvin and 700 Kelvin are 0.02 second inverse and 0.07 second inverse. The rate constant of a reaction. Calculate the values of EA and A. So we have to calculate the value of EA, activation energy, And similarly, we have to calculate the value of A. The A is nothing but it is an Arrhenius factors. Modella given data. What are all the data that they have given, we will write. So, enna data kuduthirukanga, the given. First, given. Sum poda theriyalanalu given potu formula eludunave you will get marks. So, given another 500 Kelvin. T1 is equal to 500 Kelvin and T2 is equal to 700 Kelvin, and at 500 Kelvin, the rate of chemical reaction will be is equal to K1 will be is equal to 0.02 second inverse. Yeah. At 700 Kelvin, the rate of chemical reaction K2 will be is equal to 0.07 second inverse. We have to calculate the value of activation energy and Arrhenius equation. இப்படி கேட்ட உடனே நம்மளுக்கு ஞாபகத்தில் வரக்கூடிய ரெண்டு ஃபார்முலா. What is the two formulas? First, K is equal to AE minus EA divided by RT. ஒரு formula. What is the other formula which we have derived? That is log of K2 divided by K1 will be is equal to, that is EA divided by 2.303 into R into T2 minus T1 the whole divided by T1 into T2. This is the another formula. இப்போ என்ன செய்யணும், நம்ம values பாருப்ப first we have to calculate EA. கண்டுபிடிச்ச வேல்யூவை ஈவை கொண்டு வந்து தான் என்ன பண்ணணும், ஏஇ கண்டுபிடிக்கிறதுக்கு ஐ ஹேவ் டு சப்ஸ்டிடியூட் த வேல்யூ. இங்கே டைரெக்டாக நான் என்ன பண்ண முடியாது, K1 K2 T1 T2 கொடுத்துருக்காங்க. டைரெக்டாக இந்த ஈக்குவேஷனில் ஐ கேனாட் சப்ஸ்டிடியூட் பிகாஸ் ஐ ஹவ் வாட் T1 T2 K1 and T2 K1 and K2 that is a given data in the problem. So அதனால் ஃபஸ்ட் ஈக்குவேஷனில் directly I cannot apply T1 T2 value, K1 and K2 value. So for that I have to start with this equation and finding after the value of this EA. Then this EA value has to be substituted here. So then I can find out the value of A. Okay. Now this is log of, what is K2 value? K2 is 0.02. What is, sorry, 0.07 second inverse the whole divided by 0. K1 is 0.02 second inverse will be is equal to EA. I have to find out the whole divided by 2.303. What is R value? Na erkanave eludhi potta gas constant, that is 8.314 into joules Kelvin inverse mole inverse into, what is this T2? T2 value is 700 minus 500 the whole divided by T1 into T2, that is 500 into 700. Correct? So now you divide, find out the log value is equal to, you multiply and find out the answer here. You subtract, multiply, divide, you will get the answer. You take out this EA term on the other side. So then you will be getting, when you substitute, you will be getting the answer. That answer will be is equal to 18234.8 அப்படின்னு ஒரு value you will get. This is the value of what? This activation energy 18234.8 அப்படின்ட்டு calculated value is there that they have given. So the calculated value energy should always be represented in terms of joules. இப்போ அடுத்து நான் என்ன செய்யணும், EA ஓட வேல்யூ I have identified. What is the value of this EA? EA will be is equal to 18234.8 ன்னு கிடைச்சிருக்கு. ஸோ அந்த வேல்யூவை நான் என்ன செய்யணும், இப்போ இங்கே சப்ஸ்டியூட் பண்ணணும். எப்படி சப்ஸ்டியூட் பண்ணணும் பாரு. What is the K value? K1 we have to take. K1 is what? That is 0.02 will be is equal to AE I have to find out. To the power is what? Minus EA by RT ன்னு கொடுத்துருக்காங்க. So minus EA by RT, how I can write minus, what is the value? 18234.8 divided by, what is this gas constant? The gas constant value is 8.314 into temperature is what? K1 oda temperature is what? 500 Kelvin into 500. Substitute, multiply, divide, you take the answer here. Bring it on the other side. Upper this value will come to the denominator, this value will come to the numerator. Numerator and denominator you substitute, and finally you will be getting the answer for this AE. Okay, so this is how we have to do. என்ன திரும்ப the rate constant of a reaction கொடுத்துருக்காங்க, temperature கொடுத்துருக்காங்க, you have to find out the value of EA and A. EA and A அப்படின்னு question வந்தாவே இந்த question கண்டிப்பாக கேட்பாங்க. ரெண்டே ஃபார்முலா தான் இருக்குது. ஒன்று K is equal to AE minus EA by RT, the other one is log K2 by K1 is equal to EA divided by 2.303 into R, T2 minus T1 divided by T1 into T2. So இந்த ஃபார்முலாவில் substitute பண்ணா, second formula when you substitute you will be getting the value of EA. நான் எல்லாமே values எல்லாம் போட்டுட்டேன். You have to simplify and you have to find out the answer of this EA. Second step என்னது, கண்டுபிடிச்சிருக்கக்கூடிய EA ஓட value I have to substitute in the given formula. So then I will be finding out the value of this AE, which is a pre-exponential factor or otherwise Arrhenius factor. This is how you have to do this sum. And coming to this equation, second 4.10 la irukkudiya sum, listen carefully for 4.10. The first order rate constant for the decomposition of ethyl iodide by the reaction, that is ethyl iodide decompose agudhu at 600 Kelvin is 1.60 into 10 to the power of minus 5 second inverse. So appa 600 Kelvin ingiradhu enna agum, 600 Kelvin is nothing but it becomes T1. Appa 1.60 into 10 to the power of minus 5 will become what? It becomes K1, correct? And its energy of activation also they have given, EA oda value they have given. And now you have to calculate the rate constant, that is K2 value only you have to identify. At a temperature of about 700 Kelvin, T2 value also they have given. So என்னென்ன வேல்யூஸ்லாம் கொடுத்துருக்காங்க, T1 ஓட value is given, that is 600 Kelvin. T1 கொடுத்தா K1 ஓட value கொடுத்துருக்காங்க, that is 1.60 into 10 to the power of minus 5 second inverse they have given. Then what else they have given? Then you have to find out the K2 order value. So K2 you have to find out, isn't it? K2 you have to find out, whereas T2 they have given, that is equal to 700 Kelvin, and here energy of activation, the EA value they have given, that is 209 kilojoules mole inverse. நம்மளுக்கு எதில் தான் வரணும், ஜூல்ஸ் மோல் இன்வர்ஸ் தான். அப்போ இன்டூ 1000, ஸோ 209,123 ஜூல் மோல் இன்வர்ஸ்னு ஆகும். திஸ் இஸ் தி எனர்ஜி ஆஃப் ஆக்டிவேஷனோட வேல்யூ. நவ் formula we have to apply. What is the formula that we can apply here in this sum is actually log of K2, இதுவும் நம்ம முன்னாடியே போட்டிருக்கோம், that is K2 minus log of K1 will be is equal to EA divided by 2.303 into R into T2 minus T1 divided by T1 into T2. So இந்த ஸ்டெப்பை நான் எங்கே எழுதியிருக்கேன், இங்கே எழுதியிருக்கேன், ln போட்டிருக்கேன். அந்த ln நான் log வேல்யூவாக கன்வெர்ட் பண்ணேன்னா I will be getting this. So if the value substitute பண்ணு, what is this log K2, that I have to find out. So log K2 அப்படின்னா log K2 na I am keeping as such. What is this log K1 oda value? K1 is log of 1.60 into 10 to the power of minus 5 is equal to, what is energy of activation? That is 209,000 joules mole inverse. The whole divided by 2.303 into R value is 8.314. Temperature ஏற்கனவே அங்கேயே கொடுத்துருக்காங்க. What is T1? 600 Kelvin. T2 is 700 Kelvin. So 700 minus 600, the whole divided by 600 into 700. Substitute, you keep log 2 here is equal to, you bring it this value on the other side, so then it comes to the denominator, simplify everything, and finally you will get the value of this K2. Okay, so this is how we have to do the sum. So formula வந்து first formula, second formula, three formulas temperature dependent rate constant la. So which formula we have to choose ங்கிறது depending upon the data that is being given in the question. So questionல கொடுத்திருக்கக்கூடிய data தகுந்த மாதிரி we have to select the formulas and we have to apply it in the formula. Okay, so this is for the temperature dependent rate constant. ரெண்டு sum இருக்கு, the ரெண்டு sumமும் I have done for you, so you have to study. Now we pass on to the next topic. The next topic is effect of catalyst. What is a catalyst? A catalyst is a substance which brings about the chemical reaction. or which enhance the rate of the chemical reaction. What is a catalyst? A catalyst is a chemical substance which enhance the rate of the chemical reaction அப்படினு சொல்றோம் இல்லையா அதான் catalyst. Now we'll see the effect of catalyst. Second topic is effect of catalyst. Now what is a catalyst? Catalyst is a substance that enhance the rate of chemical reaction, which enhance the rate of chemical reaction. Say for example, first example you take 2 molecules of hydrogen peroxide in the presence of KMnO4 potassium permanganate as a catalyst. It gives rise to the formation of, on decomposition, forms 2 molecules of water and then oxygen. Then similarly in a car the AC converter will be there. This converter when you take will be made up of a platinum which helps to convert the carbon monoxide to carbon dioxide. This is also another example. Platinum wires will be acting as what? A catalyst which helps in converting what? Carbon monoxide to carbon dioxide. This is the second example. Third example is most of the enzyme catalyzed reactions and the fermentation reactions, enzyme catalyzed and the fermentation reactions are all considered to be the catalytic reactions. They are all considered to be a catalytic reaction. And similarly the decomposition of potassium chlorate KClO3 on decomposition in the presence of manganese dioxide, MnO2 is called as manganese dioxide. It gives rise to the formation of potassium chloride and oxygen. So manganese dioxide here will be acting as a catalyst. So the catalyst or the substance that helps in the formation of, exam la kepanga, what is the effect of catalyst in a chemical reaction? So catalyst is a substance which helps in the formation of intermediate complex, product or a complex which further decomposes forming product. It further decomposes forming product. Second one, this catalyst will brings alternate pathway, which brings the alternate pathway for chemical reaction. Or graph. Eppadi the alternate pathway we will see now. So or graph. So here you know kinetic energy. This is potential energy. Here you know the reaction coordinating varum. Reaction coordinate. Now the reaction starts and reaction goes to the most probable kinetic energy and finally it declines like this, isn't it? Now alternate pathway, the reaction completes here. So இப்போ பாரு இங்கேயும் இந்த இடத்துக்கும் இருக்கக்கூடிய EA ஓட வேல்யூ you see. Similarly இங்கேயும் இருக்கக்கூடிய EA ஓட வேல்யூ you see. ஆல்டர்னேட் பாத்வே எங்கே வந்திருக்கு? நான் கேட்டலிஸ்ட் யூஸ் பண்ணதுனால இங்கே. அப்போ இங்கேயும் இருக்கக்கூடிய EA ஓட வேல்யூ செக் பண்ணு. What is the difference you can find out? நான் ஆல்டர்னேட் பாத்வே ஃபார்ம் ஆகிருக்கிறது நான் கேட்டலிஸ்ட் யூஸ் பண்ணதுனால அப்போ யூட்டிலைசேஷன் ஆஃப் தி எனர்ஜி இஸ் ரெடியூஸ்டு. அப்படி தானே? இவ்வளோ தூரம் போகிறது கேட்டலிஸ்ட் நான் யூஸ் பண்ணல, வெறும் ஆக்டிவேஷன் எனர்ஜி வச்சு இவ்வளோ தூரம் போய் தான் இன்டர்மீடியட் காம்ப்ளெக்ஸ் அங்கேருந்து தான் உனக்கு ப்ராடக்ட் ஃபார்ம் ஆகுது. சப்போஸ் when I use a catalyst it results in the formation of alternate pathway. பாரு ஒரிஜினல் பாத்வே இல்லை, ஆல்டர்னேட் பாத்வே. அந்த ஆல்டர்னேட் பாத்வே என்னது? ரெடியூஸ்டு ஆக்டிவேஷன் எனர்ஜி. அப்போ whenever you are using a catalyst, whenever a catalyst is used, what happens? Automatically the activation energy EA value goes on decrease. Activation energy value goes on decreases. So catalyst நம்ம யூஸ் பண்ணோம் அப்படின்னு சொன்னால் the activation energy value goes on decreases. அதுதான் ஒரிஜினல் ஆக்டிவேஷன் எனர்ஜி இங்கேருந்து இது வரைக்கும் இருக்குது. ஆனால் நான் கேட்டலிஸ்ட் யூஸ் பண்ண உடனே இந்த ரியாக்டன்ட்டோடைய பாத்வேவே வேறு மாதிரி சேஞ்ச் ஆகி ஒரிஜினல் ஆக்டிவேஷன் எனர்ஜியை காட்டிலும் தி ஆல்டர்னேட் பாத்வேவோட ஆக்டிவேஷன் எனர்ஜி இஸ் இன் த ரெடியூஸ்டு ஸ்டேட் ஆர் டிக்ரீஸ்டு ஸ்டேட். ஓகே, தட் இஸ் தி எஃபெக்ட் ஆஃப் அ கேட்டலிஸ்ட். அப்புறம் கேட்டலிஸ்ட்டுக்கு ஒரு சில ப்ராப்பர்ட்டிஸ் எல்லாம் இருக்குது. தோஸ் ப்ராப்பர்ட்டிஸ் we have to see. தட் இஸ், ஸோ இந்த நான் எழுதின பாயிண்ட்டும் ரொம்ப இம்பார்ட்டண்ட்டு. என்ன, கிராஃபில் இருந்து நம்ம தெரிஞ்சிக்க வேண்டியது என்னது? கிராஃப் மூலயமா நம்ம தெரிஞ்சிக்க வேண்டியது கேட்டலிஸ்ட் we have used. கேட்டலிஸ்ட் யூஸ் பண்ணால் EAவோட வேல்யூ will be decrease. If catalyst is used, then EA body value will get decrease. Now small amount of the catalyst will bring about the chemical change. Yeah, small amount of catalyst will enhance the rate of chemical reaction. One point. Second point, very very important, this catalyst do not alter Gibbs energy, do not alter delta G, Gibbs energy, thermodynamics principle, delta G oda value alter pannad. Delta G oda value delta G oda value is very very important because it helps in determining the spontaneity of a chemical reaction. A chemical reaction to be spontaneous ங்கிறது delta G value வச்சு தான் நம்மளால கண்டுபிடிக்க முடியும். So that means what? A catalyst will always catalyze the spontaneous reaction. Third point என்னது? It always catalyze all the spontaneous reactions. அப்போ it do not catalyze the non-spontaneous reaction. Fourth one, the catalyst do not change the equilibrium, whereas it helps in attaining the equilibrium. So do not change, very important point, do not change the equilibrium, whereas it helps in attaining the equilibrium. It helps in attaining what? It helps in attaining the equilibrium. And the last point, the catalyst helps in bringing the forward reaction or enhance both the forward and backward reaction. Forward and backward reaction. It helps in, or it enhances the forward and backward reactions. So small amount of catalyst can be used and it will not alter the delta G oda value. Catalyst will brings about the spontaneous reaction and do not change the equilibrium value, and it catalyzes both the forward and backward reaction. Okay, இதுக்கு நம்ம Arrhenius equation யூஸ் பண்ண முடியும். Same thing, K is equal to AE minus EA divided by RT. So இந்த equationல என்ன தெரியுது? Whenever a catalyst is used, then the EA, the activation energy value will get decrease. Activation energy value will get decrease. Then automatically what will happen? The rate of the chemical reaction will get increase. Rate of chemical reaction will get increase. So this is about the effect of catalyst. So catalyst na enna? Examples for the catalyst. What is the effect of catalyst? Enna pannum? What are the characteristics of catalyst? Catalyst use panni oru equation. Catalyst நம்ம யூஸ் பண்ண activation energy decrease ஆகும். Activation energy decrease ஆனா rate of chemical reaction increase ஆகும். இது I have explained. This is about what? Effect of catalyst. And the last topic which we have is the collision theory. So collision theory, next topic is, the last topic from this chapter is collision. Collision theory, according to Max Trotz and William Lewis. Next one scientist is William Lewis. In the year 1916 and 1918, they said the reactant molecules are made up of hard sphere or a surface, sphere or surface, because of which reactant molecules collides with one another. What is the meaning? So Max Trotz, William Lewis, in the year 1916 and 1918, they are telling the reactant molecules are made up of hot sphere, because of which these reactant molecules will collide with one another. The reactant moleculs will get collide with one another. They gave a new term which is called as a collision frequency. This collision frequency is represented by the symbol Z. Collision frequency will be equal to the number of collisions per second per unit volume is called as collision frequency. What is collision frequency? Collision frequency is nothing but it is the number of collisions per second per unit volume of the reactant molecules results in the formation of a product. That is the number collision frequency. Now you consider a chemical reaction, that is A and B reacts with one another, giving rise to the formation of a product. A and B react with one another, giving rise to the formation of a product. And what is this reaction? It is a bimolecularity. It is a bimolecularity. Bimolecularity reaction. For this I am applying a rate reaction. Rate will be equal to Z into AB minus EA by RT. So what is this rate? Rate is equal to Z into AB minus EA by RT. What is this Z is called? Z is nothing but it is the frequency factor or collision frequency. Then AB is the reactant molecules, EA is the activation energy, R is a gas constant and T is a temperature. Further, how I can expand this equation? That is, rate will be equal to rate will be equal to Z into K, that is equal to AE minus EA by RT. Also I can write. So what is this I have written? Rate is equal to Z into K, that is equal to AE minus EA by RT. K is what? K is a rate constant and Z is nothing but it is a collision frequency. Now based on this equation, I am going to give a definition. For the collision to take place, the rate constant should be accurately or it should be fairly equal to, rate constant should be accurately or fairly equal to the collision frequency. The rate of the chemical reaction should be, say, I will be writing now. The base panni I am giving one equation, definition. The rate constant will be fairly or accurately equal to collision frequency when the reactant molecules take the reactant molecules or atomic species or molecularity. நானே எழுதியிருக்கேன் இல்லையா, மாலிகுலாரிட்டின்னு எழுதியிருக்கேன், பை மாலிகுலாரிட்டி. ஸோ இட் இஸ் அன் அட்டாமிக் ஸ்பீஷிஸ் ஆர் மாலிகுலாரிட்டி. மாலிகுலாரிட்டி அப்படின்னு எழுதுறோம். ஸ்லைட் டீவியேஷன் can be seen complex reaction. ஸோ இப்போ என்ன சொல்கிறோம், இந்த collision frequencyங்கிறது எதுக்கு தான் applicable? The collision frequency will be applicable only for the elementary reaction where the reactant molecules are atomic species or otherwise it should be a molecularity. ஸோ அது மாலிகுலாக இருக்கலாம், இல்லை அட்டாமிக் ஸ்பீஷஸாக இருக்கலாம். அதுக்கு தான் நான் எதை அப்ளை பண்ண முடியும்? I can apply this collision frequency. It cannot be applicable for the complex reaction. ஸோ அப்போ அந்த காம்ப்ளெக்ஸ் ரியாக்ஷனாக இருந்ததுன்னா then effective collision P, probable effective collision அப்படின்னு சொல்கிறோம். effective collision should be applied. அது என்னது ப்ராபபிள் எஃபெக்டிவ் கொலிஷன்? இந்த ப்ராபபிள் எஃபெக்டிவ் கொலிஷன் அப்படிங்கிறது பேஸ்ட் ஆன் த கைனடிக் எனர்ஜி ஷுட் பி கிரேட்டர் தேன் தட் ஆஃப் தி ஆக்டிவேஷன் எனர்ஜி, ஃபர்ஸ்ட் கண்டிஷன். த செகண்ட் கண்டிஷன் இஸ் ப்ராப்பர் ஓரியன்டேஷன். இது ரெண்டுமே இருக்கணும் காம்ப்ளெக்ஸ் ரியாக்ஷனில். ப்ராப்பர் ஓரியன்டேஷன் ஆஃப் தி reactant molecules. ஸோ ப்ராப்பர் ஓரியன்டேஷன் and the kinetic energy should be greater than that of the activation energy இருந்ததுன்னா காம்ப்ளெக்ஸ் ரியாக்ஷன்ஸில் எஃபெக்டிவ் collision will takes place. அதுக்கு ஒரு எக்ஸாம்பிள் இருக்குது. What is that example? We will see now the example. Formation of methanol. Formation of methanol. Formation of methanol. You take H, 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 Br combines with this OH minus. அப்போ எனக்கு பாசிபிலிட்டிஸ் பார்த்தீங்கன்னா 2 different products. என்ன 2 different products? C, H, H, H bond Br minus OH minus. So here this is partially negative and this is also partially negative and this is partially positive. So மைனஸும் மைனஸும் ஒரே டைமில் அட்டாச் ஆகும்போது there is a repulsive force, அதனால் bond formation இருக்காது. இன்னொரு பாசிபிலிட்டி என்னன்னு பார்த்தீங்கன்னா C, H, H, H transition state, partial bond formation Br minus OH minus. This is considered to be an intermediary product. From this the main product enna H, 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 OH plus Br minus. So the product is CH3OH is methanol. CH3OH is methanol உடைய formation you can see. அப்போ இங்கே பாரு என்ன இருக்குது, இந்த கைனடிக் எனர்ஜி. ஸோ அட்டாக்கிங் ஆஃப் திஸ் OH takes place opposite to that of the Br minus. அப்போ it give rise to bond formation, partial bond formation, leaving bondலேயே there is a partial bond breaking இருக்குது, partial bond which I call it as a transition state. ப்ராப்பர் ஓரியன்டேஷன் தான் இங்கே H வருது, இன்வெர்டட் கான்ஃபிகரேஷன் H இங்கே OH Br. ஸோ ப்ராப்பர் ஓரியன்டேஷன் இஸ் ஆல்சோ தேர் which results in the effective collision which is called as the P, probable effective collision அப்படின்னு சொல்கிறோம். இப்போ இங்கே நம்ம ஹரினியஸ் ஈக்குவேஷன் அப்ளை பண்ண what will happen, that is rate is equal to P into Z into AE minus EA by RT. என்ன நல்லா இருக்கு, probable effective collision and this is collision frequency and this is Arrhenius frequency factor, activation energy, gas constant, temperature. The rate of the chemical reaction depends on all these factors. Probable effective collision, frequency, collision frequency. Next one is Arrhenius frequency factor or pre-exponential factor, activation energy, gas constant and temperature. So this is called as what? Collision theory. So collision theory la ஞாபகம் வச்சுக்க வேண்டியது என்னது? Collision theory, normal collision theory is what? Z, and the Z value is applicable only for what? The elementary reaction where the reactant species or atomic or otherwise molecular state. Suppose complex irundaduna, then the kinetic energy value should be greater than that of the activation energy and it should have a proper orientation. So இந்த கான்செப்ட் எல்லாம் ஞாபகத்தில் வச்சுக்கணும். ஈக்குவேஷன்ஸ் எதுக்கு என்னென்ன ஈக்குவேஷன்ஸ்னு தெரியணும். And all these things you have to take down in your notebook and you have to study. With this the lesson gets over. In my next class I will do all the 30 sums. With that we will continue with P block elements. Okay, so take down everything in your notebook. Thank you.